Hello everyone. Today we are going to start with a new chapter, new module, that is AC circuit analysis. DC circuit we have already covered. If you want to ask any doubt or any question related to BT or BE, then you can call me on this number. This is my number. Okay, and if you want help in makeup exams or in any another exam, maybe for BE, PET, physics, maths, chemistry, BME, then also you can contact me on this number. I'll help you. If you want notes of this series, then also you can call me. And if you need any guidance, if you need any important question kind of stuff, then also you can contact to me. Okay, so let's start with the single phase AC circuit. So let's start for the single phase AC circuit. From this तुम्हारे पास क्या क्या questions आते हैं? Just see. There are three types. Like one is the series RLC based numerical that will come in your paper. Then maybe the parallel based RLC circuit will come in your paper. Then after that you'll have the topic of resonance that will come in your paper. Then you'll have the topic of power factor improvement that will come in your paper. Okay, so now basically if you'll consider, there are three topics, okay, four topics. From these there are 95% chance, maybe 95 to 100 you can say, that this question will come. ओके इसका एक पर्टिकुलर पैटर्न होता है जो हर क्वेश्चन के लिए सेम होता है, दैट आई टेल यू. देन parallel RLC based circuit, again in this, for this particular topic you will have 90 to 95% chance कि जो पैटर्न आता है मणिपाल का उसके बेसिस पे आई एम टेलिंग यू. ओके for resonance, again there is 70 to 80% chance, and for series also that would be 70 to 80% chance. One more topic is there, that is waveform based question. Like they'll give you the waveform and you have to tell the output, तो उसका chances is also 80%. ठीक है, so 1 2 3 4 5, these are the 5 topics. From these 5 topics, 3 topics will definitely come in your exam. 3 topic 100% आएंगे ही आएंगे. Only I'll focus, mainly I focus on these 5 topics. Rest of the topics I'll also cover, but mainly मेरा focus इस पे रहेगा, because every time this would be a repeating. Okay, fine. So if you see from this one, तो इसमें से समझ में नहीं आएगा. This is your syllabus part कि क्या है क्या नहीं दिया हुआ, that I'll tell you one by one. So before that, studying AC circuit, we should know that what is basically the resistor, what is basically the inductor, and what is basically the capacitor, right? Because we are going to learn about the R, L, C in series. So R is the resistor and its unit is ohm. L is the inductor and its unit is Henry. C is the capacitor and its unit is farad. Correct? Generally, they'll give you inductor in the form of millihenry. So 1 millihenry is equal to how much? Can you tell me? 1 millihenry is how much? 1 into 10 raised to power minus 3 Henry. Next is farad. Generally, they'll give you farad in microfarad. So 1 microfarad is how much? 1 into 10 raised to power minus 6 farad. और ohms तो ये ohms में ही देते हैं. Okay. So see, I'll ask you one question. If there is a plain wire and if there is one wire carrying resistor, okay, in which case, first case or the second case, current would be able to flow easily? Tell me. Like there are two options. There is a plain wire and one wire is carrying resistor. So in which case current can flow easily? First case or second case? Tell me. First case, right? Because there is no fluctuation or there is no nothing, कुछ भी नहीं है रास्ते में, और current can flow easily. Similarly, I'm telling you, asking you basically कि if there is a plain wire and if there is a inductor वाली wire, ठीक है, तो in which case current can flow. So basically, हाँ, like for 2 hours, yeah, same. It's in both in the steady state condition. Okay. From the very long time, from the very, हाँ, but अभी उसको अभी ट्रांजिएंट वाले पार्ट को भी हटा दो, जनरल आई एम आस्किंग, ठीक है. So, in this case, obviously the current will flow easily in the plain wire. That means there is some amount of resistance present in the inductor which opposes the flow of current. Yes or no? मतलब तुम कह रहे हो कि प्लेन वायर में आसानी से करंट फ्लो हो रहा है, तो इसका मतलब इंडक्टर के अंदर कुछ ना कुछ रेजिस्टेंस है, राइट? वी डिडंट ऐड एनी रेजिस्टेंस टू द इंडक्टर, तो उसके अंदर इनबिल्ट रेजिस्टेंस है which opposes the flow of current. Correct or not? So that particular resistance is technically known as inductive reactance, and inductive reactance is denoted by XL. If I'll write the define of inductive reactance, what is that? That is the resistance offered by inductor. Can we say that? Inductive reactance is the resistance that is present in inductor, or it is the resistance offered by the inductor only. Correct? So we'll have the XL ka formula. XL formula is omega into L. Omega is what over here? Omega is equal to 2 pi f into L. So omega is basically the angular frequency, and omega का formula you all know about it कि omega का क्या formula होता है, that is 2 pi f, and f is the normal frequency. Okay, so now can anyone tell me that what should be the unit of inductive reactance according to you? Now I'm again asking, if you'll have a plain wire or the capacitor wali wire, then tell me in which case current can flow easily, the plain wire or the capacitor wire? Plain wire, right? Current can flow easily in the plain wire. So that means there is some amount of resistance present in the capacitor also, and that is known as capacitive reactance. And capacitive reactance is denoted by XC. X is for reactance and C is for the capacitance. Again, we'll have particular formula for that. Xc is equal to 1 by 2 pi Fc. It is also the form of resistance, so its unit is also ohm. If I'll write down the define for this, it is the resistance offered by capacitor, that is known as capacitive reactance. Okay, understood this thing? Tell me. Okay, so ultimately if we'll have resistor, then we'll have resistance. If we'll have inductor, so inductor ka resistance is XL. If we'll have capacitor, so capacitor ka resistance is XC. XL formula is omega L, that is 2 pi FL. XC formula is 1 over omega C, that would be 1 by 2 pi FC. Okay, all these are the forms of resistance, so its unit is ohm. Up to here, you need to remember these formulas and concepts. Okay, after this, what if suppose we'll have the combination of R and L, okay, and the combination of R and C, and the combination of R, L, C, because these are the loads and किसी का भी combination we can have. तो इनका resistance is denoted by the term Z, and Z all of you have studied, Z is denoted by impedance. Z क्या होता है? Impedance. 12th क्लास में पढ़ा था ना impedance. तो बेसिकली व्हाट आई वांट टू से कि रेजिस्टर है तो रेजिस्टेंस, इंडक्टर है तो एक्सएल, कैपेसिटर है तो एक्सी, बट इफ विल हैव द कॉम्बिनेशन ऑफ एलिमेंट, ओके, then in that case their resistance is technically known as impedance. Okay, so particular formula for the impedance is, for the case of RLC it would be R square plus XL minus XC का whole square. But if there is a case of R and C, then Z would be equal to क्या होगा? Tell me. R square XC square, because there is no L. L नहीं है तो XL also would be 0. Similarly, for the case of RL, tell me Z would be equal to For the case of RL, tell me Z would be equal to R square plus XL square. Okay, and their unit is also ohm. Understood? Write down this thing in your formula page. Again, I'll suggest to you कि make one separate formula page जहाँ भी तुम लिख रहे हो copy में, last page उसमें formula की heading डालो. Like write down the heading formula, and then we are starting with the AC circuit, तो put a heading की AC circuit की formula है, and then write down these formulas, क्योंकि last में बहुत सारे formulas इकट्ठे हो जाएंगे तुम्हारे पास, then you won't be able to grasp it. ठीक है? Understood? So write down these formulas. Now see after this तुम्हारे पास इसमें will have lots of formulas, so you just need to remember one impedance triangle. From this impedance triangle all the formulas are automatically learned. ठीक है? अब देखो impedance triangle I am drawing, it's a kind of right angle triangle. बस ये याद करना है, then you don't need to cram all other formulas. सारे formulas तुम्हारे यहीं से ही आ जाएंगे. Okay, and as you know that very few formulas are mentioned in your handbook, right? So ultimately you need to cram the formula. In impedance triangle, impedance means it's a kind of resistance. So base में क्या आता है? Resistor, resistance, and in the perpendicular we'll get inductor का resistance. Now tell me, what is the inductor का resistance? XL, right? Or we'll have XC, okay? And at this hypotenuse side we'll have the combination of RL, RC or RLC. Now tell me, इनके combination के resistance को what we have denoted by? That is impedance, Z, and angle is phi. Like suppose if we'll have the RL circuit, पेपर में अगर तुम्हारा RL circuit है, then impedance triangle would be, here would be R, here would be XL, and here would be Z, right? But if we'll have the RC, then in case of RC, in the base we'll have resistance, perpendicular can be XC, and this would be Z, that is phi. And if you'll have the case of RLC, तो इस केस में we'll have resistor, we'll have XL और XC दोनों ही होंगे. तो if XL is greater, then you need to do XL minus XC. If XC is greater, then you need to do XC minus XL. Okay, that depends which one is greater, and this one would be impedance. Okay, yeah. Now see, as you can see that this is the right angle triangle. So can you tell me the value for sin phi? Can you tell me the value for cos phi? Or can you tell me the value for tan phi? As you already know what is sin phi, cos phi, tan phi. What is sin phi? Yeah, so if I want to calculate sin phi, तो मैं एक standard इसका लेके चल रहा हूँ XL minus XC का. Okay, So you can do it by the same way. That is perpendicular over hypotenuse. That would be XL minus XC by Z. Cos phi would be R by Z. And tan phi would be XL minus XC by R. Yes or no? So this is the trick that you don't need to remember. Okay. Because if you know the impedance triangle, you can also calculate like this. But if they want to ask you the phi, okay, phi is the phase angle between, yeah, they वाला phi है. तो चाहे sin phi से निकालो, or you can use cos phi, or you can use tan phi. Answer will be same for all of the cases. Okay. Suppose if I'm calculating phi by cos phi, so in that case, phi would be equal to cos inverse R by Z, and cos inverse you can easily perform in your calculator, right? So you can use any of the formula for calculation of phi. That depends on you, or depends what you know the values. If you know R and Z, then you will cos phi. If you know XL and R, then you will use this formula. Correct? Now again, this is right angle triangle. Can you apply the Pythagoras theorem over here? What is Pythagoras theorem? Hypotenuse का square is equal to perpendicular का square plus base का square. Hypotenuse is Z का square, right? Base is R का square, and perpendicular is XL minus XC का whole square. So if I'll remove it, Z would be equal to root of R square plus XL minus XC का whole square. See, it's the same formula जो मैंने यहाँ पे लिखवाया था. So this formula also you will get it from the impedance triangle. So again, you don't need to remember any formula. You just need to cram this impedance triangle only. Correct? Okay. So write down all these formulas in your formula page, because this will help you to solve the numerical. Okay. If you multiply current with the resistance, what you will get? Tell me. I into R is what? Voltage, right? So if there is a impedance triangle, that is R over here, Z over here, and XL minus XC over here, again I am taking the standard thing. If I multiply all this term by current, then this impedance triangle would be converted into the voltage triangle. Yes or no? So this would be how much? I into R. This would be I into Z. This would be I into XL minus I into XC. So what is VR? VR is the voltage drop across resistor, and VR ka formula is I into R. Correct? What is VL? VL is the voltage across inductor, and its formula is, क्या formula होगा VL का? Again according to Ohm's law, I into R. तो inductor है तो inductor का resistance will take it, so that would be I into XL. If there is VC, that would be voltage across capacitor. That would be कितना होगा? Tell me, what should be the formula for VC? I into XC. And what is the V over here? V is the total voltage. So total voltage is V is equal to I into Z. So technically, if I'll see, this would be VR, this would be V, and this would be VL minus VC. And again, this is phi. So this is voltage triangle, right? So from this also, can we get sin phi, cos phi, and tan phi? And can we apply Pythagoras theorem in this? Now apply Pythagoras theorem in this impedance, in this voltage triangle, and then tell me what formula you will get it. VR by V. Yeah, so particular in this case, if we'll apply the Pythagoras theorem, then in that case V would be equal to VR का square plus VL minus VC का whole square, right? And you can get sin phi, cos phi and tan phi also. ठीक है? And this would be phi. Now tell me, if I'll multiply voltage with the current, what it will become? V. No, power. V into I is power. V is equal to I into R. ठीक है? Now if we'll नहीं नहीं उसने गलत बोला था. So if we'll have the voltage triangle, if I'll multiply voltage triangle with the current, तो अब हमारे पास क्या आएगा? बोलो. If I'll multiply voltage triangle with the current, then what will get? Power, right? So before telling you the power triangle, I would like to explain. We'll have mainly three different types of power. Okay. One of the power is active power. Another power is reactive power. Can you hold for 1 minute? No. Okay, done. One of the power is active power, another power is reactive power, and another power is apparent power. Okay. Active power is denoted by P, reactive power is denoted by Q, and apparent power is denoted by S. Mark it important क्योंकि पेपर में इस पे based one question you will definitely get. Active power का will have formula, that is VI cos phi. Reactive power का will have formula, that is VI sin phi. Apparent power का will have formula VI. Active power is used where we are using resistive load. Reactive power is used where we are using inductive or capacitive load. Apparent power will use where we are using RL, RC or RLC load. Okay. Now the question is ki where we are using resistive load? At our home appliances. Like we are using bulb, fan, AC, all these are the home appliances and all these are based on resistive load. Where we are using inductive or capacitive load, mainly motors or you can say in industries. ठीक है? Factory वगैरह में we'll use it. And where we are using RL, RC और RLC वाला load, that is ट्रांसफॉर्मर में. कहाँ यूज करते हैं? ट्रांसफॉर्मर में. एक्टिव पावर इज ऑल्सो नोन एज रियल पावर और ट्रू पावर. एपरेंट पावर इज ऑल्सो नोन एज कॉम्प्लेक्स पावर. रिएक्टिव का बस एक ही नाम है, दैट इज रिएक्टिव ओनली. ओके. नाउ यू टेल मी that in the power triangle, which power we should write it over here in the base. Base is basically for the resistance. So resistive load के लिए कौन सी power we are using? That is active power. That is denoted by P, right? And in the perpendicular we are using inductor and capacitor. So for inductive and capacitive, which power we are using? Reactive power, that is denoted by Q, and the total power is the apparent power, that is denoted by S. So if I'll apply the Pythagoras theorem, tell me what would be the formula for the Pythagoras theorem? S square is equal to, and cos phi would be, and sin phi would be Q by S, and tan phi would be Q by P. R नहीं है, power. Okay, clear? Any doubt? So see, in तीन power triangle से, one is the impedance triangle, another one is the voltage triangle, and another one is the power triangle, right? So from these three triangles, all the formulas of series वाले तुम्हारे इसमें आ गए, that you don't need to cram. थोड़ा सा तो करना पड़ेगा, but I tell you the tricks. ठीक है? Now one more thing which they'll ask you in Manipal, that is power factor. Okay, so power factor is basically cos phi. What is cos phi? Cos phi is the cosine of angle between voltage and current. What is phi? Phi क्या होता है? एंगल बिटवीन वोल्टेज एंड करंट. जैसे यहाँ पे तो तुमने इसकी टर्म्स में लिया, ये फाई है, ठीक है. तो पावर फैक्टर क्या होता है? कॉस फाई. तो अगर एम्पिडेंस ट्राइंगल है देन यू नीड टू यूज कॉस फाई, दिस वन फॉर्मूला. वोल्टेज ट्राइंगल है तो कॉस फाई का अलग फॉर्मूला होगा. इफ यू आर यूजिंग द पावर ट्राइंगल देन कॉस फाई इज पी बाई एस. नाउ द क्वेश्चन अराइजेस कि मैम हम एम्पिडेंस ट्राइंगल से निकाले, वोल्टेज ट्राइंगल से निकाले या पावर ट्राइंगल से निकाले तो आंसर वुड बी सेम. बताओ आंसर सेम होगा या अलग अलग होगा अकॉर्डिंग टू यू? सेम ही होगा. तो तुम कोई भी ट्राइंगल से निकाल लो, दैट टोटली डिपेंड्स ऑन यू, विच एवर यू वांट. ओके फाइन. ठीक है. ओके, नाउ आई एम गिविंग यू वन क्वेश्चन, बेसिक क्वेश्चन दे रही हूं मैं अभी विद द डायग्राम. नोट इट डाउन. दिस इज द सीरीज आरएलसी सर्किट. अभी जो हम टॉपिक पढ़ रहे हैं दैट इज सीरीज आरएलसी सर्किट. ओके, in this they have given this resistance is 10 ohm. Okay, this is a coil. Whenever they said na ki coil hai, तो coil is always the combination of R and L. This is 2 ohm, L, 10 ampere. Voltage across resistor is 120 volt. एक minute. So this is your question from 2023 makeup exam. Now अभी हम ये consider कर रहे हैं कि diagram is not given, circuit diagram is not given, only they have given you the statement. So now I am telling you how from the statement we need to convert it into diagram. Okay, now they said a circuit consists of a pure resistor. Okay, pure resistor means only the resistor, whatever they have given in the form of statement that you need to write it down. And a pure inductor. Pure inductor means the only inductor, and a capacitor and capacitor are connected in series. Okay, we have also connected in series. When the circuit is supplied with 100 volt, now the total supply voltage is how much? 100 volt. How will we show the AC supply? ऐसे शो करते हैं. डीसी के क्वेश्चंस शो करे थे तो डीसी सप्लाई वी हैव शोन इट लाइक बैटरी फॉर्म. एसी के विल शो इट लाइक दिस. सो दिस इज हाउ मच? 100 वोल्ट. फ्रीक्वेंसी इज हाउ मच? दे हैव गिवन 50 हर्ट्ज. तो जब भी वोल्टेज और फ्रीक्वेंसी देते तो हम इस तरह से यहाँ पे लिखते हैं नीचे. ओके, ऑलवेज. नेक्स्ट दे सेट कि द वोल्टेज अक्रॉस इंडक्टर and resistor are 240 volt and 90 volt. The voltage across inductor is how much? 240 volt. And voltage across resistor is how much? 90 volt. Now you know the formula of VR, right? And you know the formula of VL. Can you tell me what is the formula for VR? I into R. तो मैं ऐसे इंटू नहीं बना रही क्योंकि वो एक्स से तुम लोग कंफ्यूज हो जाओगे. I into R. And now tell me what is the formula for VL? I XL, right? I into XL. Now VR they have given is how much? 90 volt. And VL is they have given is how much? 240 volt. And the total voltage how much they have given? 100 volt, right? And frequency they have given as how much? 50 hertz. Okay. Now they said if the circuit takes 10 ampere, means the current flowing in the circuit is 10 ampere leading current. Leading lagging I'll tell you later on. Means if I is given, that is how much? 10 ampere. Now see, if I is known to you 10 ampere and VR is also known to you 90 volt, can you get the value for R? Hmm? I is given, 90 volt is given, basically VR is given. If I'll write down the formula, VR is 90 volt, I is 10 ampere. Can we get the value for R? Okay, similarly, if VL is given 240 volt, XL is I is given again 10 ampere, because it's in series, current would be same. Can we get the value for XL? Tell me. Hmm? Tell me. Can we get the value for XL? VL we know, I we know. Can we get it? XL? Okay. And what is the formula for XL? Tell me. We just studied XL is equal to 2 pi FL. If we know XL, if we know 2 pi, if we know frequency, can we get the value for L? Hmm? Okay, do it up to here. See, 0. We get the value for R, that is 9 ohm. They have asked you resistance. We get the value for L, that is 0.076 Henry. Now we need to calculate capacitance. तो मैं उस पे थोड़ा होच पोच हो रहा था. Again I am copy pasting this. Now what we need to get? The value for capacitance, right? We need to calculate C. But C के लिए हमें पहले क्या चाहिए? We want VC, right? Because VC is equal to I into XC. If we know the value of VC, current we already know 10 ampere, then easily we'll be able to get the value for XC. But before that, we should know the value for VC. VR they have given, VL they have given, but they don't give you VC, right? But we can calculate VC by which formula? Go to the voltage triangle and tell me which formula we can apply to calculate the VC. See it? Yes, the Pythagoras theorem, impedance voltage triangle ka, that is V is equal to VR square plus VL minus VC का whole square. Voltage triangle में क्या था? This is V, this is VR, this is VL minus VC. Remember I told you? So if we'll apply the Pythagoras theorem, V we already know 100, VR we already know 90 का square, VL we already know 240, VC we can get it. Can we get it VC? Bolo. From here can we get the value for VC? ये long हो जाएगा because तुम्हें quadratic equation you need to calculate. So don't need to calculate, do it in your homework, but I'm just telling you the concept. So from here you will get VC, then you will get XC, and XC का formula is 1 by 2 pi FC. तो यहाँ से जो भी XC की वैल्यू आएगी substitute it here, then you will get C. यहाँ तक बोलो. Any doubt up to here? Clear? Okay. Next in the B part they are asking power factor. Power factor is what? That is cos phi is equal to, कोई भी formula लगा लो. Like see the voltage triangle. Tell me according to the voltage triangle what would be the formula for cos phi? VR by नहीं VR by V. VR we already know 90 volt. Total voltage also we know, that would be 0.9, right? And power factor is unitless. Cos phi is power factor. Now they are asking voltage across capacitor. Voltage across capacitor means they want to ask VC. Okay.